This sheet is supposed to kind of guide you through how to complete the square. And the first section is really just supposed to really be a guide for the parts of the process. And then the second part is supposed to be, basically that's one use of completing the square, is just solving equations. We're going to skip all over all that. Look at the back. I'm going to do a couple problems in the back, and then this is going to be due Thursday. Okay, just the back. So here, I'll do number 11 to start with, if I can write. And I'm going to start with what goes in Part A. If you look at the top of the page, Part A says group-like terms, and so the x terms get grouped together. On number 11, you have an x squared plus a 4x. Group those together, leave a space, plus the y terms, so y squared plus 2y, leave a space. And they have parentheses the way they do it. I'm not going to put the parentheses right now, we don't really need them. And then the 20 is moved to the other side. Okay? And that right there, that little thing where you move the constant over, you switch the sign, it's little, but you screw that up, and now your whole thing is screwed up. So I'm just saying, you've got to stop making little mistakes like that. On the test, there's one little thing I'm going to harp on tomorrow. Basically, on the distance part, I'll just show you real quick. It looks like this. And how to write it the way it was. It's like cosine of 5 pi over 6 or something like that. And what people did is said, oh, that's 4 cosine 5 pi over 6. You cannot combine these. You can't do the subtraction. Why? Because you have to multiply first. You know that, but seriously, listen. You know multiplication comes before subtraction, but you don't see the multiplication. What you see is 34 minus 30 standing out there. And so people do that first, and then the whole thing's wrong because they didn't know the order of operations. That's what I'm saying. Be careful about little mistakes like this. By the way, I forgot, I wasn't going to do number 11. I was going to do number 13 because it's harder. And so, there, you already have Part A done at 11. Now do Part A on 13. So put this in blank A. And then, group it, leaving a space. And then whatever the constant is, just move it to the other side. Okay? That's the starting point. That's what Part A says to do. And then we're going to complete the square. I'll start with the y's first because they're easier, frankly. Let me just remind you, our goal is to get something of this form. In this case, the 2, you take half of it, you'll get a 1 there. And before I keep going, let's just establish this. Y plus 2 squared, if you simplified it, you get y squared plus 2y plus 1. I'm saying this equals this. So all I need to do is I'm trying to make it so this can be rewritten in this factor form. What's missing? The 1. So I'm going to add 1 to both sides to complete the square there. And then, like I said, this is the factor form of that trinomial. Now, I come over here, it's harder because the constant in the middle term has a 1 there, an odd number. If I take half of that, I get a half. So once again, take half of b goes there, and then b squared goes here. Well, yeah, 1/4. 1 squared is 1, 2 squared is 4. So positive 1/4 goes there, and you add that to both sides. And then the right side really just works out to 1/4, and we are done. Now, I'll tell you right now, the purpose of this worksheet is simply to practice this skill, completing the square and equations like this. These are all equations for circles, and so when we do other shapes, the equations will look a little different, but the same basic idea. Okay? Just for practice, by the way, you don't have to do this on this paper. All you got to do is get the equation. But the center of this circle would be 1/2 comma -1, and the radius would be 1/2, because that's r squared sitting there. All right, look at number 16. 16 is going to be different. We're going to, Part A, and actually put this somewhere else, like above the blank for Part A, because I don't want this there yet. Group the x's together, leave a space. The y's, there's only one, there's just y squared. We're not going to have to complete the square on the y, so just leave it there by itself. Move the 7 over, it becomes negative. Okay, so there's your setup. Then what I'm saying is on blank A, I would write this in factor form. And what I mean is, whatever the coefficient is in front of x squared, you need to factor out everything. And you're not even thinking of it being a common factor. In this case, it is a common factor too, bless you. But that's not what we factored out. If this had been a 7 here, or a 3, or a 5, you still would factor out the 2, which would leave you a fraction here, but that's what you would do, okay? So I'm just telling you, whatever the coefficient is, you factor right here, all right? Now, like I said, this I want to see in part A, blank A. What you get after you regroup it and factor. Now, this is a little bit trickier. Let me just bring the 2 down. This part's going to become x plus, well, 2 squared. Okay? But it's not there yet. Here's my question. Listen carefully. What I want to know is not what goes here, but what would have to go all the way up here so this works out the way we just described. Good. Yes. Because what goes here is a 4, but for that 4 to be there after factoring 2 out, you'd have to have an 8 originally. And so you don't have to show the work this way, but I recommend it. Because if you don't show this step, and don't put the 8 up here, then what you're likely to do is put a 4 here and put a 4 here, which is wrong. The other way to think about it is simply that you put a 4 here, yes, but the 4 is inside parentheses where everything got doubled. So in reality, you added 8 to both sides. And so putting a 4 over here instead of an 8 is a big mistake, a very common mistake. And so just like I said, showing all this work is the safest thing to do. You're more likely to not make a mistake, but it's up to you. Last thing, we don't leave it like this. We need to get rid of those coefficients. So divide through by 2. And now you have it in the form we want. This is what goes in blank B. It is just x plus 2 squared plus y squared equals 1/2. And that's the equation in standard graphing form. Listen, when I grade this, I'll tell you right now, all I'm going to be looking at is the answer in part B. Like I said, the purpose of the worksheet is kind of guide you towards the answer. The intent of blank A was this to be there, but I don't really care. Set it up, do the work, get the right answer. I don't care how you show the work as long as it's valid work that gets the answer. Okay? Like I said, there, the back of the worksheet is due on Thursday. We need to talk about conic sections, and frankly, I've got new notes, and I got something that'll show it, but all I have is my old standby physical model that shows this. They're called conic sections because there are different ways to slice a cone. They're sections of a cone. All right, so just watch. If you take a cone and slice it parallel to the base, you get a circle. So a circle is considered a conic section. You cut it at an angle. That was nice. Then you get an ellipse. So an ellipse is another conic section. This equation is similar to that for a circle, but not quite the same. If you slice it parallel to the other side, you get a parabola. That's one thing you understand. You've done parabolas before since algebra 1. But not the way we studied them here. They have different properties. They have a focus. They have directrix, which you don't learn about when you normally study them. So you'll learn more things about parabola. And then the other thing you need to understand is, in reality, what you have is 2 cones. One up, one directly above it. And if you slice at a steeper angle, so you hit both cones, then you get what's called a hyperbola, okay? Which looks like 2 parabolas, one going up, one going down, but it's not. And it can go this way too. The parabolas can go anyway. The whole thing can be rotated whatever you want. But my point is, the parabola has certain properties. The branches of a hyperbola have different properties. One huge difference right off the bat is that hyperbola has asymptotes. Parabolas don't have asymptotes, so like I said, it's not the same. The names sound similar, the shapes look kind of similar, but they're not the same. A hyperbola is not 2 parabolas. Okay. Now we're starting with parabolas, and I had you copy down the definition. If you didn't already do so, there's blanks to the top of the paper. Copy that down now. So there's a geometric definition of a parabola. Set of all points in a curve that are equidistant from some point called the focus and some point called the directrix. Remember the definition of a circle? Set of all points that are what? Yeah, same distance from some point that we call the center. It's an easy definition for a circle. What I'm saying is we go through these shapes, they all have some geometric definition. Here, that's what makes a parabola a parabola. Every point on it is the same distance from some point called the focus and some line called the directrix. Now, we're going to draw, basically draw a diagram out of parabola, do the anatomy of parabola. If you look at the back of your packet, the bottom of the back, that'd be a good place to put this. Like, so we're going to use this as, a homework packet, but we're just going to put the notes on it. I'm going to do some of these problems as examples. So on the bottom of the back, in that space that's there, we're going to draw a parabola. What I want you to draw first is the focus. So put a point, you can just put it right about there. Call that the focus. And label it to the right of the point like I just did, except for spell it correctly. And then over here, about that far, draw a vertical line. There's your directrix. Okay? Now, I'm going to put a point here halfway between, and that point must be on the parabola because every point of the parabola is equidistant from these two things. The distance from the focus must be equal to the distance from the directrix, which, by the way, let me pause. If you're talking about the distance from a point to a line, by that we mean the shortest distance, the perpendicular distance, right? Like I said, this point is on the parabola because that distance matches that distance. That's where I put it. This distance, by the way, we call P. I put a B here. This is the vertex of the parabola. And it's the shortest distance. It's the closest point in the parabola to the directrix and the focus. Okay? And so that distance is special. All right, now, if I want to draw this parabola, first of all, I'll tell you right now, the parabola is going to open to the right. It's kind of abnormal from what you did probably in Algebra 2. I need more points. What I want you to do is, let me do it this way. If I was like in line with the focus, I'm going to draw a little line. If I was anywhere on this line, if it's parallel to the directrix, but goes to the focus, I'm 2p away from the line, yes? The distance is 2p. So if I want to go up here, somewhere above the focus, and be on the parabola, how far must I be from the focus? 2p. What is a parabola? Set of all points that are equidistant from some point called the focus and some line called the directrix. I'm saying if my point's anywhere in this line, then it's 2p away from the directrix, right? If I make it also, here, draw this, make it also 2p, so you're going to make like a rectangle, not a rectangle, square. So that is 2p. Put this far away so this appears to be also 2p. I'm saying at this point that I'm drawing here is the same distance from the directrix and from the focus, then it's on the parabola. And if I go 2p the other direction, once again, same parallel, then I must have found another point in the on the parabola. Because that's 2p and this is 2p, and then I'm on the parabola. And now you can draw your parabola. So you can go through that point. Hold on. Through that point, through the vertex, and through that other point. There it is. A couple more things we can add to our picture. One is the axis. This thing's a horizontal parabola, so it has a horizontal axis of symmetry. Let's see. And a couple things to note about that. The axis goes through the vertex. Actually, it also goes through the focus. Those 2 points, the vertex and the focus, are both on the axis of symmetry. Okay. And actually, what I'm talking about, the focus is always like in the direction of the parabola. It's on the inside of the parabola. Okay, so if the parabola opens to the right, then the focus is to the right of the vertex. So you should just know that. Now, one more thing we need to label on this, and that would be, if you connect across from this point all the way to this point, that segment has a name. And you're going to love this. It's called the latus rectum. Latus as in quadrilateral. Yes, it's a defining name. So like quadrilateral, it's like a length, a side, a segment. Rectum as in like rectangle, perpendicular. And this is the segment that goes through the focus and is perpendicular to the axis. Hence the name. How long is it? 4p. And write that down. Remind yourself when you need to know that for one thing. But also, when I say the latus rectum, I don't mean just the halfway across, but all the way across from this point in the parabola to the other point in the parabola. Okay? All right. I want you to look at the front of the paper, the table that's there. There's two kinds of parabolas, horizontal and vertical. This is a horizontal parabola. So you see the equation, the form of the equation that it should go with? Now, frankly, I like writing like this. So back in the, next to this, I'm kind of switching around. I like having the square term on the right. But a horizontal parabola will have an equation of this form. Basically, it's x equals y squared. And that's a huge thing, is knowing which kind of equation you're supposed to use. The kind that has y equals x squared, or the kind that has x equals y squared. All right. We're going to do number 1 as an example. Hold on. Now, before we get started, I want you to understand, these equations look strange to you, I'm assuming. Let me show you how they would have looked if you saw them in Algebra 2. First of all, the coefficient, usually it goes over here. And frankly, there's different ways to write these equations. And our old book wrote it like this, or at least this way we typically did it. We put the coefficient over here. And then watch this. If I move the 7 over to get y by itself, then you have this. The plus 7 here. That should look more familiar, yes? And as far as like, where's the vertex? You think I hide over. The vertex, you do the opposite of this. So it's positive 3 for the x and a positive 7 for the y. Write that. You don't write all this down, but write that down on the blank for the vertex. That is correct. But we don't look at the equation like this. We don't even look like this. We're going to stick with the form that is written in. And so, once again, the vertex is just the opposite of what you see. And all the conics are going to be that way. That's one reason we write it this way. Instead of having y equals, then it's just consistent across all the conics. Now, before we can do anything else, well, actually, before I even do that, I was going to say we need to find the distance. But we need to figure out which way this thing goes. So does it open up, down, left, or right? So first of all, tell me, is it a vertical or horizontal parabola? Vertical, because I told you, if it's y equals x squared, so if x is squared, then it's of this form, that's normal, that's vertical. Is it up or down? How's the coefficient? So it opens up. Write that down somewhere, that it opens up. That is huge. If you don't get that right, then everything's going to be wrong. Okay? I'm serious. And then you need to find the distance. Look, this coefficient equals 4p. If your equation is in this form, then that's 4p. And if 4p is 12, then what is p? And what does p represent again? The distance from? Yeah, exactly. And so, but that's how you find it from the equation. It's just, that's 4p, so you divide by 4. But that means, here, let's draw this first. The vertex is at 3, 7. So put that there. If it opens up, then the focus is above it, 3 above it, in fact. So where's the focus? 3 comma what? 10, right? If you go 3 above this point, you're at 3 comma 10. That's your focus. And then with the axis, by the way, it goes right through those 2 points. It's a vertical line. Look, the axis always goes to the vertex. In this case, it's vertical, so it's x equals that x value. And then the directrix. It's the line that's the same distance below, the other side. So the focus was 3 one way, you go 3 the other way. But draw a line to it. So the axis was vertical, so the directrix is a horizontal line. I would label it D. Maybe label this as A, or you can call it the axis. What's the equation for the directrix? Y equals what? No. The vertex was at 7, the focus is 3 above it, the directrix is 3 below it. Now, I need points on the parabola. How far is the focus from the directrix? 6, right? So if I go at 6 from the focus, straight across, put a point, then I found a point in the parabola. I point 6 in the focus and 6 in the directrix. Go 6 the other way. 1, 2, 3, 4, 5, 6. And there you go. Those must be on the parabola because, once again, they're equidistant from the focus and the directrix. And then you draw your parabola, connecting those dots. And the last thing is the lattice direction. It's always 4p in length. It is a distance, by the way, a length, so it's always positive. How far across was this? 6 and 6 is 12, yes. Or it's just 4 times p. Frankly, this will be the length of the lattice direction, except for it's never negative. And there you go. Now, one thing I want you to understand is, think about this. When I wrote it in this form, you had y equals 1/12 x minus 3 squared. Think about it. You never drew a parabola with a 1/12 coefficient. It was always like 1, 2, 3, 4, maybe a half, but not a 12. And so trying to draw this parabola the old way would not be nice. It wouldn't work out nicely. It's theoretically possible that you would want to. This is much better. Conversely, doing something like number 4 is not nice to do this way. There. I'm doing number 4 next. And I understand most of these you'll want to do the way I just showed you. Is that y plus 5 squared, is that right? Okay? All right, first thing, which way does it open? Up, down, left, or right? It's horizontal because it's of the form x equals y squared, negative coefficient, so it opens left. Write it down. It may seem excessive to write that down, but it's that important. I would write it down. All right, where's the vertex? -7. There you go. And be careful. X and Y kind of switch places on these equations, so just be careful. Now, we're going to go and draw the parabola now. Plot the vertex. And it's going to open to the left. Before I draw this, let me show you again how to draw a parabola normally. So, here, let's just say I'm just going to draw y equals x squared. Okay? It's the parent function. And so there's your vertex at the origin. But really this applies no matter where the vertex is. It doesn't matter. From the vertex, if you go out 1, then you go up 1. 1 squared is 1. If you go out 2, though, you go up 4. 2 squared is 4. And if you went out 3, 3 squared would be 9. And that's how you get your points on the parabola. And you go the same thing other side. You go out from the vertex, you go up 2 squared is 4, away from the vertex. And so if the coefficient's 1, that works every time. So that's all I'm going to do, except for I'm going horizontally. So if I'm 1 away, I go out 1 in the direction the parabola faces, so plot those points. And if I'm 2 from the vertex, I go up 4. Puts this a little bit off the grid. So I'm saying if your coefficient's a whole number, I want you to draw your parabolas like that. using the old way. Okay, that's just sad. I can do this, I can. Oh my god. I'll take it. Yeah, that really is. Okay. I'm just failing. All right. Let's fill in the other blanks now. First of all, if 4p is 1, which mind you, I'm just using the coefficient, but ignoring the sign, then p is 1/4, right? Which is going to be kind of a pain. Where is the focus in relation to the vertex? Left, right, above, or below? To the left. If the thing opens to the left, the vertex is to the left. I mean, the focus is to the left of the vertex. Well, if I go 1/4 to the left of this point, the x value gets 1/4 smaller, which is just that. Not very useful. The directrix is that same distance the other way. So if I draw a vertical line, which I'm not going to draw, it'd be just 1/4 to the right of -7. It'd be -6 and how many fourths? And it's on the same horizontal line, which, by the way, the axis is that horizontal line that contains these 2 points. Wait, I just messed up horribly. The directrix is a line. That's sad. I'll be using pencil. So there, that's what not to do. These 2 points are both on the axis. And then this point in this line are equidistant from the vertex. This point was 1/4 to the left of the vertex. This line was 1/4 to the right of the vertex. Now, watch this. If I wanted to actually draw the lattice rectum, by the way, is just 4p, which is 1 in length. It would be like half unit above to half unit below. That's how the focus would be right here, 1/4 unit to the left of the vertex. And you go half unit above, half unit below. Those would be. It's not a very good way to draw a parabola. You're not going to get, you get to go in the right direction. That's all you get from that. You want to get a good sense of how wide it should be, So I'm saying, a problem like this, I don't want you using the lattice rectum and the focus to get the thing drawn. Most of these, you will be using this new skill. Plot the vertex, plot the endpoints of the lattice rectum, and then draw your parabola. Okay? Number 4 is an exception to that. All right. Turn the page. Actually, look at 26. What does it give you? The vertex is what? Is that right? And then the focus. All right, listen, all you have to do on this is get the equation right. But first, you really need to draw a sketch, okay? -9, -4 is, let's say there. And then where is this focus in relation to that point, in relation to the vertex? It's below, right? It's 3 below. Okay. That's what I'm saying. Make it concrete. Put it on the paper. Draw it. If the focus is below, the parabola opens down. Okay? If you don't know that, you're going to get the wrong equation. It's just wrong. If you don't have the right form of the equation, then I'm just going to mark it wrong, probably. So, if it's vertical, we put y minus something squared. It's y equals x squared. Yeah. Right? So this general form. And by the way, the vertex is here. So the 4 goes here, but it's minus -4, so plus 4. Over here you have the x minus h, but that's plus 9 squared. The biggest thing to not forget is the negative sign because it opens down. So you might even put that as the very first thing. As soon as you know it opens down, put the negative sign because, like I forgot it last period. It's that easy to do. Now, we're almost done. We need this. That's 4p. How big is p in this problem? Well, just make it positive, so 3. Yeah. It's a distance, so we'll just, yeah, yeah. So it's 12. Negative 12 just because the thing opens down. And we're done. Question? Let's do BB, problem BB. Now, just so you understand, all these problems come from the book, except for sometimes the book doesn't have all the problems we want, all the kinds of problems you want, so we'll supplement it. And we're not going to give a number because you'll think it's that problem from the book, but it's not, because we made it up. So that's why they're numbered like that. So on problem BB, you're given a focus of -2, -8, right? And you're given the directrix. What is the directrix? All right, let's draw this thing first. -2, -8. This way is down here. The directrix is a horizontal line. Don't mess that up. Up here. Right? This point would be below that line, yes? So the vertex is halfway between those, and the parabola opens down again. So let's get the form set up. It's a negative since it opens down. I think I just recommend doing that. Put the sign there immediately when you write out your form. And once again, if it's vertical, it's y equals x squared in form. So y, well, we don't know the vertex yet, do we? Now, first of all, the axis is this vertical line here, right? This vertical line goes through both the vertex and the focus. So it's the axis is the line x equals -2, since it goes through the focus. That means the vertex has that same x value. What's the y value? Good, very good. Where is the vertex? Halfway between the focus and the directrix, right? So make sure you're doing midpoint formula. Between this y value and this y value. Okay, let me try again. -8 plus -2 divided by 2 gives you -5. Because I would recommend writing that down, or at the very least, if you guess at it, you think you've got it right, double check. Once again, this y value should be equidistant between this y value and the y value for the line, and it is. It's 3 below the line, 3 above the point. Check that. I'm serious. People on this, when I ask that question, what's halfway between 8 and 2, -8, -2, they'll say -4, they'll say -6. Very common mistake. So check it. Just make sure it actually is the same distance. Okay? And by the way, that means P is 3. Just like I said, the vertex is 3 away from each of those, so P is 3. Now we can write our equation. First of all, if P is 3, then the coefficient is 12 again, because you put 4P there. It's not always 12, but it works out nicely with that, so it's common. And then what goes here? And then equals x squared, but it's x plus 2 squared. And we're done. All right, listen, and we're going to stop there as far as examples. You need to get through CC by tomorrow, ideally, okay? At least practice all this by tomorrow, because tomorrow I'll be showing you other things about parabolas. We have a few days. This packet, we have 3 days to work on altogether. So I'm saying this is just the first part of the notes. So I can't just give you all the day tomorrow to work on that first section. So tonight, do a good part of the beginning up through CC. Okay?